Hey guys, Mr. Mises here, and in this lesson I'm going to be talking about the absolute extrema and not the mean value theorem. The mean value theorem will be on the next video. On this video I am just going to be talking about absolute and relative extrema and using what we call the critical number test, or the candidate test. So we're going to here's some terms that you need to get familiarize yourself with. So if you can, make sure you look at these terms. I'm not going to keep it on this page for very long, and you could pause it and then take a look at that so we can get through the examples that I have. The procedure that we're going to use is we're going to find absolute extrema. We're going to find our critical numbers, and we're going to do that by taking the derivative and set it equal to 0, or to see where it's undefined. Then we're going to find the y values at each critical number and at each endpoint in the interval. And then we're going to just choose the ones that are the least and the greatest to find the absolute extrema. All right? A couple of things. The absolute extrema can occur either at the critical numbers or at the endpoints. Relative extrema can only occur at the critical numbers, so we won't consider anything at the endpoints any relative extrema. So let's take a look at some examples. What are the absolute extrema of... Sorry about that. What is the absolute maximum of f? Remember, the absolute maximum is a y value. So the absolute maximum of f is this y value here, which is 4. What is the x value at the absolute maximum? Well, right here, there's the x value at our maximum value of absolute max, so that's negative 4. What's the point? The point is negative 4, comma 4. What is the absolute minimum of f? Well, notice here we don't have... Right here would be, close to here would be an absolute minimum, but this is an open circle, so we really don't have an absolute minimum. So I'm going to put there is no absolute minimum. And what values of x? Does f have a relative minimum? Well, the relatives are right here. Right here. All right, so we have negative 3, 1. And that's it. So only at the critical numbers. Well, let's see. Derivative. And then the derivative is undefined right here. So we're going to have it at 2 as well. What values does x have a relative maximum? The relative maximum is going to be right here at x equals negative 1. And then there's no other relative maximum because we can't have this point right here. And the endpoint cannot be a relative maximum. So the only one we have is negative 1. All right, let's take a look at how we're actually going to do this with some derivatives. So let's find the global extrema. Global extrema means the absolute max or the min on this interval for this function. So the first thing we're going to do is take the derivative. So we're going to take the derivative, x squared minus 4x, and we're going to set that equal to 0 to find our critical numbers. All right, so our critical numbers are 0 and 4. Okay, so what we're going to do is we're going to take f of negative 1, f of 0, and f of 3. We're not going to worry about 4 because 4 is not in this interval. So we're just going to worry about these 3 numbers. So we're going to go and plug in negative 1 in here, and that's going to give us about negative 2 1/3. We're going to plug in 0, and we're going to get 0. And we're going to plug in 3 in here, and that's going to give us a negative 9. All right, so what does that tell us? Well, the biggest value here out of these 3 is this one. So this is going to be our absolute max. The smallest value here is this one. Okay, so this right here is our absolute min. Okay, and that's all we do. But it's very important that when you show this work, you show your derivative to find your critical numbers, and then you show the values that you get when you plug in each of the endpoints and your critical number. Okay, this is the candidate test. Now let's try another one. So find the absolute maximum, absolute minimum values of this. Now this one we know is an absolute value. Shift it over like this, and I believe this is going to land at 2. We got 3 here. So already by the picture, we know that our absolute maximum is going to be here at 3, and our absolute minimum is going to be here at y equals 0. Okay, so how would we figure that out? Well, if we took the derivative of this, notice we have an absolute value. So we know that when x is less than 2, the derivative is going to be equal to -1, and when x is greater than 2, the derivative is going to be +1. Right? We see the slopes here anyway. Okay, so what we're going to do is we're going to use 2 as our critical number here, because that's where it changes slope. So I could do f of 0, f of 2, and f of 5. And when we do that out, we're going to get 3, 0, and 5. So we see clearly that this is the min, absolute min, and this right here, 5, is our absolute max. All right, so we found our absolute min and max. All right, next one. Find the extrema of f of x equals, okay, so now we're asking for the extrema. So we can find relative or absolute. We're going to find all of them. So let's go ahead and do that. And the first thing we do is we take our derivative. So our derivative is going to be 2x to the -1/3 minus 2. And we're going to set that equal to 0. All right, when we solve that, we're going to get 1 over x to the 1/3 is equal to 1. Now we know x is equal to 1 is a solution to this. So this is a critical number. However, this is undefined at x equals 0. So this is also a critical number that we must check, because it's where the derivative is undefined. Excuse me. So we're going to check our values. We're going to check f of -1. We're going to check f of 0. We're going to check f of 1. And we're going to check f of 3. So we're going to plug all those in. And when we plug all those in, I did the math here. F of -1 should be 5. F of 0 should be 0. F of 1 should be 1. And f of 3 is around 0.24. Excuse me, I got to get the phone. All right, phone call has been taken care of. So we've got these numbers here, and let's go and take a look. What is our absolute max? All right, right here, we've got our highest y value. So we've got our absolute max. What is our absolute min? Well, that's right here, right? So that's our absolute min. And what is our, do we have any other things? Well, we have this here. And this is going to be a relative. Relative what? Well, lower than this is 0, and that's going to be coming. So if we're at 0, 0, and f of 1 is 1, then we're coming up to it, right? And then f of 3 is going to be at like 2.4, so then we're going to come down to that. So this looks like it's a relative max. Okay, so this one's nothing, right? This one's nothing because it's not the biggest, it's not the smallest, and it can't be relative because it is an endpoint. All right, let's take a look at the last one I have for you on this video. Find the global maximum and minimum of g of x equals 2 sine x minus cosine 2x. So this one takes a little bit of work here, guys. So I'm going to try to not rush through it too much. But we're going to take the derivative. So we're going to get 2 cosine x minus 2 sine, plus, because it's the derivative of cosine, is sine 2x. And then I have to do the derivative of the inside, so we got chain rule, equals 0. Now this one's a little tricky. In order to solve this, I am going to use the double angle formula, which is 2 sine x cosine x. And that's going to allow me to factor out 2 cosine x and get 1 plus 2 sine x and solve for x. When we solve for x here, we are going to get x equals 7 pi over 6 and 11 pi over 6. when we solve that sine of x equals negative 1/2. And then over there on the cosine x equals 0 part, we're going to get pi over 2 and 3 pi over 2. So, oops, that's not what I want. We're going to get pi over 2 and 3 pi over 2. So then we're gonna do g of 0, because that's the endpoint. Then we're gonna do g of pi over 2, g of 7 pi over 6, g of 3 pi over 2, g of 11 pi over 6, and finally the last endpoint of g of 2 pi. All right, we got to do all of these, and we're going to plug these into, we're not going to plug them in anywhere. We're going to plug these values in here, and we're going to use our unit circle. You know, it's really, really important that you can use the unit circle to figure this stuff out, because you're going to have to do it on the AP exam. So g of 0 is going to be negative 1. G of pi over 2, when we plug that in, we're going to get 3. G of 7 pi over 6 is negative 3 halves. 3 pi over 2 is going to be negative 1. G of 11 pi over 6 is going to be negative 3 halves. And g of 2 pi is going to be negative 1. All right, so let's take a look at that. These seem to be the smallest, and this one seems to be the biggest. So right here we have an absolute max. The absolute max is 3 at x equals pi over 2. And the absolute min, the global mins, we've got 2 of them. Now they can be the same number. That's still global. They're the lowest they could possibly be, right? So we've got a global min at negative 3 halves, and at the x value of 7 pi over 6, and the next value of 11 pi over 6. But our y value for our global min, sorry, did I say x? I meant min. Global min is going to be negative 3 halves. All right. So that is using the candidate test to determine absolute maximum minimums. We'll talk to you later, guys. See ya.